Okay, so hello and welcome everybody once again. My name is Oleg Ishchuk. I am Chief Operating Officer at SDC Verifier. Today I'm joined by my colleagues Petro, Victoria, and Bohdan, who will help me to guide you through today's topic. I'm going to demonstrate the capabilities of SDC Verifier together with ANSYS for global analysis and structural verification according to standards for the offshore structures. Today's session will be mostly focused on the tips and tricks on different analysis setups, how you can simulate different behaviors of the structure, how you can do multiple analysis at one project, and how you can solve tricky engineering tasks with SDC Verifier and FEA program. And obviously we'll cover the idea of structural members recognition and code checking and demonstration of the results. If you, by default, you're muted on entry. If you're having any questions, please type them into a chat box or send it to, I think you can send it to host or to presenter. And we'll also have a couple of minutes in the end of this session to go through your questions and discuss all of these topics. So let's go directly to the demonstration. The only thing I always want to remind you, I'm showing today the structural verification of demonstrational model with ANSYS mechanical, but everything I'm showing to you today is also possible to perform with FEMAP, SimCenter FEMAP, and SimCenter 3D. So SDC Verifier works with three FEA programs, and all the functionality I'm showing today is also available for FEMAP and SimCenter 3D. So today we're going to speak about this model. It is a combined beam and shells model with sort of a beam structure on top and the foundation built with plate elements with some stiffeners and ribs inside. Pretty simple mesh. It took me about, I'm not extremely advanced user of ANSYS, and it took me about half a day to build this model from scratch. So with broad functionality of ANSYS or FEMAP or SimCenter, you're able to build your FEA models with fine mesh from step files, geometry files, drawings, or just new design from scratch within a reasonably quick time. And preparing a simulation is pretty easy task. But then you have next steps. You have you need to verify your model according to rules and regulations, and you also have to simulate different behaviors of this type of structures, because it's not only the operational conditions where you apply some pressure, gravity, winds, wave loads, and operational loads, but structure also has to pass through other analysis. And among those analyses, there are analyses like installation and retrieval. That's why we have these ropes. There is transportation cases when the structure has to be delivered to the place where it starts its operation. There is obviously operational loads itself. There are some testing loads. There are impact conditions. There could be some damages or other conditions to your model, and you want to do all this evaluation, all these sorts of analysis within one model, one structure, and of course also verify it according to rules and regulations like AISC, API, ISO, ABS, DNV, and so on. So today I'm going to speak about two tricky analysis. I'm going to explain the installation and retrieval analysis, one of the workflows, how you could do this, and I'm going to explain the transportation analysis. So as we see, our model in its operational condition is basically plate foundation and the lattice structure on top, but this structure has to be installed into a seabed, or it has to be lifted, it has to be mounted somewhere for the operation. So for these cases, we have a lifting case. And our model is having some pad eyes and connection points, and with the ropes, it is lifted and installed in some place. So it's pretty easy analysis because we have all we have to do is to lift it with this point, with the ropes, check the displacements, deflections, and so on. But there is one trick. Sometimes it's not equal lift. Sometimes the lift is skewed and you have unequal, well, center of gravity is obviously is not in the center, but even if the center of gravity is directly under the central point, the ropes could be different. One of the rope could have some damage or whatever. You have different unequal lifting situation. So today I would like to show to you a case when we have unequal lift with a certain percentage of skew. So what I did at the beginning, I applied a minimum set of constraints that are necessary for this model to be solved. I pinned one node here on top, and I disallowed the displacements in X and Y direction for this corner and in Y direction for this corner, just to avoid any rotation and to be able to run this lift. But as I said, we have a situation when the lift is unequal. Not all the ropes are having the same force. And to solve this, I made the following trick. I connected two ropes diagonally in diagonal form. I connected these two ropes, yellow ones and this orange ones, in different locations. So if you would take a look on the model, what I actually did, I connected these 2 points slightly above the other 2 points. And the bottom node I have pinned, so X, Y, and Z movements are disallowed. And to the top node, I have applied a force which is exactly the magnitude of this force is exactly the value of the weight of my structure. So I basically applied a compensation or skew force on top of it to these two ropes, and the bottom two ropes, the yellow ones, I have pinned. This allows me to create loading conditions with different percentage of skew on diagonally oriented ropes. So as most of you already know, SDC Verifier completely repeats all the loading conditions of the FEMAP ANSYS or SimCenter model. So for my first installation and retrieval analysis, I have a couple of constraints, which I showed to you before, and the force on top. In SDC Verifier, we basically have two forces, which is gravity and compensation force. Compensation force is this uplift. Gravity is obviously the weight of the structure downward. So in this case, then I did couple of loading combinations to simulate different conditions. So let's go to edit the load sets. I will create edit multiple. So first of all, I apply the gravity and compensational force with a factor of 0.5, which simulates completely equal lift. 50% is going through the bottom node of constraints, 50% is going through the compensation force. Then I applied gravity and full compensation force. In this case, 100% is going, 100% is going through this lifted yellow ropes. Another combination I did is 62% of 62% skew. And with this logic, you could do whatever skew you would need, 90-10, 30-70, and so on. And then obviously these loads are having some factors. You need to apply the amplification coefficients, dynamic coefficients, extra load when it's going through the splash zone, extra load for retrieval from the water, and so on. So I just applied a couple of coefficients like to the equal case and to the case of 62-37%. So I multiplied that with 115 for installation lift. Then I did the same with factor of 1.5 with some dynamic coefficients. Then I did it with factor of 2 through the splash zone and with factor of 1.3 for the retrieval. So basically I have multiple cases, multiple combinations when I'm allowing the equal and unequal lifting with different factors. Then I grouped these factors into three conditions, into three groups. In first group, I have all the installation loads, so with factor 115 and 1.5, and then I grouped together the splash zone, and I grouped together the retrieval, and maybe we would like to have another group where we include everything all together and call it overall worst case. For those who are not aware of SDC Verifier combinations, load sets are linearly combining the separate influences of your FEA solution, and load group is showing the overall maximum of everything what's included in the load group. So here I can study every single influence on my model. Here I can study the combinations, and with load groups I can study the worst scenario of everything what's included in that load group. And to prove that this is correct workflow, I build a simple table where I am checking the reaction force in the component of pinned node. So the weight of my structure, getting back to this lifting case, is 16.8 tons. And you can see that in case of 50-50 lift, in vertical direction, I have 83 kilonewtons of the force. So exactly the half of the weight is going through the pinned node. In case of 100 to 0, exactly 0% of the force is going through the pinned node. So it's completely lifted with two diagonal ropes. And in the third case, approximately, well, exactly 37.5% of our 16 tons is going through this pinned node. So this allows me to build whatever I would like to see. Also, I can control this loads and check the reaction force in that node for all the other loads. So I added everything. I'm pressing fill table, and I see what is the force that is going through. That is going through that pinned node for different cases. So this one is obviously the biggest because I applied it with the factor of 2, and it's pretty significant load at that bottom node. Okay, so this is a scheme that allows me to build a model for the transportation, for the lifting and the retrieval condition. And next one, I want to show you another job. It's the transportation. So this structure has to be also transported.
Yes. Sorry to interrupt. I wanted to know the connections, how it has been connected between the shells and the beams. If you could throw some idea on that, it would
Between
be
the
great.
shells and the beams of the model over here.
Yeah.
I think it's just a bonded contact. I haven't paid that much attention to this. In this case, it's a contact, and in this case, we connect it with the rigid body elements, which has allowed all rotations on the end. So it stimulates the pin.
And how about this all along the beam, the connection between the shell and the beam all along? Because I believe this will be
Here.
welded to the bottom structure. Yes.
In my case, I think there is a contact. So, well, yeah, in my case, there is a contact. It's not welded. But if you would like to, you can set up, yeah, you just need to split the mesh of the surface in a certain, uh, under the center line of this beam, and make sure that the mesh size is exactly the same for the beam and for the plate, and just merge the nodes. So this is an example model, so I didn't pay that much precision and attention to the details, but yeah, it's a good questions, and this connection is important to for the general deflection and behavior of this structure.
So right now it's bonded contact.
Yeah.
Okay.
Now it's bonded contact, but it's up to an engineer what you would like to do. You can merge the nodes and connect it together, or you can play with different contacts and different models. Thank you, Ajay.
Okay. Thanks.
Um, yeah, so another analysis I wanted to perform is transportation. So this structure has to be transported by a barge to the place of where it operates. And for this, we have to do two things. First of all, we need to remove these ropes. We don't need them in the analysis. And there is two things. In in FEMAP, it is possible to, when you're working with FEMAP and SimCenter, it's possible to work with the selection directly from SDC Verifier and just exclude elements that you would like to exclude. In ANSYS, you have to do another step is in your analysis settings, or yeah, in the analysis itself, you can play with element birth and death, this option, and include or exclude the elements which you don't need in the solution. I also did this through the APDL command, just because, yeah, we're used to doing these things. And with APDL command, it's also possible to exclude some elements from calculation. So I excluded 4 elements from all the steps that I had in my model. And basically, I just, this 4 elements, I will hide them for the moment, but I excluded them from the calculation, and then I applied a pinned constraint on the corners to assume that this has fixed connectors on the corners to connect it to the barge. What do I mean by this? Basically like that. In every corner of this model, I applied a pinned connection to simulate some sort of a connection to the barge. And then I applied 3 loads. I applied translational accelerations in X, Y, and Z direction. For some analysis, for example, in our engineering practice, we also did this sorts of transportations, but very precise for ship-to-shore cranes, and we also applied rotational acceleration. So basically, from the barge owner, you will receive the acceleration loads, which takes into account all the conditions along the transportation, and you are able to apply this translational and rotational accelerations in your FEA program. So basically what I did, I just applied the X, Y, and Z accelerations, 3 directions, and then I received, let's assume that I received the factors of this the values of these accelerations from the barge owner. So I created the next, in SDC Verifier, automatically the next solution is treated as a separate job. And in this job, I have, well, I have 11 loads, but because I was playing with other items of this model, but I need just 3 accelerations, which are accelerations in X, Y, and Z direction. And then I combine that into different conditions like barge movements when the structure is placed longitudinal on the barge, and when the structure is placed when the structure is transverse on the barge. Also, you can recreate this condition with even more cases, like you can have it pointed, because the position of on the barge will also influence the values of accelerations, because it will be different. Rotational accelerations will be different on different places. But I just assume that if I have it on the outmost corner, I have the highest possible rotational and translational movements, and I did just this too. But if you want to do a really, if you're transporting 20 of these things, you need to be sure that each and every of this is fine, so you can take into account also the positions, and the factors of the loads will differ. But what we have to do, we basically just apply a percentage of g acceleration in every direction with a certain factor, positive or negative. So my ANSYS model has just 3 accelerations applied and solved. And if I need to add more of these conditions, no problem at all. I can copy these rows. I can name them position 2 to all of them. Well, it takes some time for renaming, but you can export it to Excel, rename, and import back. So different position, same loads, and then just modify the values. Then it's going to be more severe, 71, 35, and so on. Typically, you will receive a PDF file or Word document with this table already. So all you have to do is just copy them from these factors from the document you received from the barge owner or operator, and paste them wherever you need into your group of loading combinations. And in this way, we created 8 more cases, but in reality, we have customers that are doing 400 cases for this type of jobs, and it's basically whatever amount of combination is necessary for you, it's possible to perform them. So as I said, this allows you to simulate any barge movement, any translational or rotational accelerations with any sort of factors. You can do the other way around. You can apply every load, every influence as a separate load, but that's obviously influence your calculation time. That obviously influence the amount of loads you have to apply. So this trick is much more convenient, because you just apply 3 accelerations with unit loads, and then with factors you do the combinations that you need. The same trick can be done here, because I apply the compensation force of 165 kilonewtons, because it exactly matches the weight of my model. But through the redesign process, adding and removing things, this the weight of the structure can change. So maybe it was more wise just to apply 100 kilonewtons of a force, and then play with the factors of load sets to be able to simulate any compensation force that you have, and it doesn't require from you the recalculation of the model. So this model is pretty simple. It has maybe 20,000 finite elements, and also just because I have pretty good mesh and for the shell model, but some of the FEA models could be 20 million finite elements with hundreds of loads, and it's time consuming to recalculate the model. With this approach, you don't need to get back to recalculation to adjust the loads. You just apply the factors, you play with the coefficients, and you create whatever amount of combinations is necessary. So this was the explanation how we can simulate a couple of tricks. In the same way, you are copying this job of transportation, just doing duplicate. It is connected, it is immediately created in Workbench. You reconnect that with SDC Verifier and create your next case. Is it the operational load, test load, whatever other conditions you might need? Apply new loads of the operations, solve it, and keep it within the same project. So This approach allows you to have every operational condition or every simulation of your structure within the same model and do different behaviors, do different simulations. And then for all of these simulations, you obviously need to comply with the rules of standards. So to do this, two more things has to be done in SDC Verifier. First, you have to go to the recognition and find all the beam members on the model. We go to beam member finder. On my model, I already have them recognized, but I'll clean that just for you. So to show you how quick that is, I remove everything. All you have to do with SDC Verifier beam member finder or any recognition tool is just press find. Yes, we will also update. Yeah, this one is fine. So 51 beam members has been recognized in our model, and I can check them. I can select length Y and preview them with the colors. So plot members, plot selected members with length criteria or with IDs. Let's just plot. So many plots, hard to pick one. Let's plot. Yeah, let's just plot the selected members with the colors. Takes a second, and we see each and every member that SDC Verifier is recognized and will be used for beam member checks. This member is highlighted with different colors. And you see, well, maybe it's smarter to do it with IDs just for a second, because I want then to show you that SDC Verifier is not only recognizing the members, but it also takes into account the direction. So we see that here it's one member 36, but it's having for length Y, but it's having two connections that are splitting this member. So if I'll take a look on length recognition for that direction and preview here with length criteria, I will be able to see that this member actually consists of 3 submembers. Colors are not the best. It actually contains 3 submembers splitted in Y direction. Over here, you could see that, in Z direction. So SDC Verifier is not only defining the lengths of members from connection to connection, but it also takes into account the direction of this connection to determine the buckling lengths. So I did a recognition of beam members. Next thing I would like to do also to find the panels on my model. Basically it's already done, but the logic is the same. You press find and all the plates in your model are recognized. You could go here to the plates, see all the plates in your model. I just want to highlight to you how the recognition is done. We'll plot them with the colors. Yep. So SDC Verifier took into account this stiffeners or ribs at the bottom and automatically recognized the plate dimensions for plate buckling check. We can also see here that it's not properly recognized because this stiffener, there's 2 separate stiffeners. One is going through this distance, then we have a small hole, and there is another one. So what we can do, we can manually edit this. So to find that plate, first we need to plot it with ID, I think. Find that plate and manually split it. So these are the plates number 1411. So I go to plate number 1411. And we see that it's 5.5 by 1 meter long. And here I have split selected plates by nodes, split selected plates by elements, by order. I can select 2 nodes to split the plates. So I'm not going to go through the full process because it's not the topic of this webinar, but you see, well, maybe if I already started, let me finish presenting this. So I'm selecting this node and then that node. I hope that's fine. Press yes. And SDC Verifier has automatically splitted that plate. If I will plot it with colors once again, I will see now that my split has been done. So the idea is that recognition is pretty much automatic, but you always have a full control over this. So if something should be splitted as you think, if something should be modified, it's always possible to adjust, it's always possible to modify, to edit, and to improve the recognition tools. After I did the recognition of beams and plates, I need to go through the standards, and I have already created a couple of, but SDC Verifier has an extensive list of different offshore codes, including ABS, AISC, API, DNV rules for fatigue, plate buckling, weld strengths. We have Eurocode, which is pretty common for everyone, ISO, NORSOC, and so on. So if I want to do a plate buckling, for example, DNV, I select DNV, plate buckling, I define the safety factor, I define the sections from the recognition that I would like to use. Let's say everything. Thickness factor if necessary, and do I want to use plate average stress or not? I'm pressing OK, and the standard of DNV plate buckling is created. Here we have a check, and I can create, this is basically DNV plate buckling of 1995, but there is a newer one, DNV RPC201, and here we also have a stiffener buckling. The logic is pretty much very similar. You have to define a couple of parameters and you create another standard. Then you could do the AISC. Well, I already have one, so let's add the Eurocode. Add Eurocode members check. For the members, you have to define a couple of parameters like fabrication type. Let's say that all of our beams are rolled to all. Manufacture method, let's say it's hot finished. Do we have any fillets? Can be 0. Section net area if necessary to set. I just press OK. And material type. It's already defined. Yes, press OK. So every standard has some customizations, some parameters to define. And then for each and every of these loads that I have created, so I have only installation and transportation, but for a big project, you would have here also the operational conditions, test conditions. You can copy the transportation and let's assume that you have 2 different barge operators who are offering different size of barges and different roads and different accelerations. So you can have, you can just copy this transportation and do it with another setup. So the logic of jobs in SDC Verifier allows you to create multiple simulation scenarios and then to easily and quickly adjust it with loading combinations, factors, and load groups. And then for all of this functionality, of course, you have the standard SDC Verifier way of presenting the results. So I'll just do one. Let's assume that for installation, for equal, let's take the worst one, skew splash zone. You can create a stress plot, for example, say criteria plot for stresses, equivalent stresses, let's default view. I'm not going to adjust anything, just clicking to preview plot. And SDC Verifier starting to build this result plot. The same idea is for creating the tables. So all the functionality of SDC Verifier in terms of presenting the result is here and is still available for you to present this. So we actually see that stresses during this skew lift or skew retrieval with factor of 2 are pretty high. We are about 320 megapascals in the connections. So maybe some extra attention has to be paid for it. Maybe you need to adjust the cross section. Also, it can be done using SDC Verifier optimization tool, where you are able to adjust and modify. Well, presenting of the results and demonstration of the reporting capabilities and optimization tool is a matter of different discussion and of a bigger webinar for another hour. I just wanted today to present to you the idea of multiple loading conditions, combinations, and workflows, some tricks on how to implement different scenarios for analysis with using SDC Verifier load factors and combinations, and to remind you that it's easy to recognize the structural members, it's easy to create a standard and present the result either for general FEA or for evaluation according to rules and regulations and standards. At this point, I'd like only to remind you a couple of things. There is a lot of new people at this webinar. If you're not yet an SDC Verifier customer and you're eager to learn more about SDC Verifier capabilities, feel free to send me a message after this webinar. I think we'll also contact you with an email after this. We'll send you the recording and we'll send you some information that has been presented today. If you would like to learn more, if you would like to have a detailed demonstration on standards, on reporting or recognition of structural members, let us know and we'll arrange this set. And in terms of presenting the results or the behavior of the model, I would like to invite you to the next webinar. We are trying to keep the space with webinars pretty intense, and every month we are presenting new feature of SDC Verifier. So in a month, on 22nd of June, we will be presenting to you the post-processing tool of SDC Verifier, especially peak finder and governing load. So we'll explain you how to present the peak results of your model, how to understand the composition of loading for this peak results, and how to define the crucial loading cases for your model out of a big amount of loading combinations. So we'll send you another reminder, tune in for the next webinar. But for the moment, if there are still any remaining questions, maybe Petro, you can help me to read the questions from chat or the ones you received in messages, if there are any.
Yeah, one moment. One question is, it's what is the maximum amount of loading combination that can be combined with SDC Verifier?
Okay, yeah, that's a really good question. I already tried to explain that with creating more over here. So we have like 11 load sets or 16 load sets for transportation. But for transportation case, if we would take into account multiple positions of the structure on barge or much more acceleration patterns, we would have much more conditions. As I said, one of our customer is having about 400 load sets, and I have tested SDC Verifier with 10,000 loading combinations. So basically, this amount of loading combinations is fairly unlimited. You can create tens of thousands of these combinations. It's of course a matter of result presentation, and that's why you would need a governing load tool to understand which loads are crucial to your model. But yeah, answering your question very briefly, the amount of loading combinations is fairly unlimited, and you could do whatever amount is necessary. That's the idea of our loading combinations. Anything else?
One more. It's about can I store the calculation scheme for another model?
Yeah, that's another nice capability. I haven't demonstrated that, so it's good that you asked. The idea of SDC Verifier itself, I think a lot of you have seen the circle of SDC Verifier workflow, that any workflow that we've done like combining the loads or recognizing the structural members or standard setup, is template based and it's stored, so you are able to do whatever analysis you did, you are able to repeat it for another model. So for example, if you have another design of the structure, or you have tens of different structures that has to pass the same analysis, it is possible to copy the model itself or to load the new model into your Workbench project. And it's possible to duplicate SDC Verifier projects for that system or export this system to the other model. So SDC Verifier can be launched, can be connected to whatever analysis you have. If you have more of models, you can copy the same template of SDC Verifier project for any of the model that you are using. And also, it is possible to do this for FEMAP and for SimCenter. Basically, you just open SDC Verifier file as template. There is option which is called Open as Template, and you are opening the same SDC Verifier project for another FEMAP or SimCenter model. So yes, it's possible to run the same analysis for multiple design iterations or multiple different changing models. Yeah, let us know if there are any more questions. I also see that some people at these sessions are, well, there is a lot of already users of SDC Verifier, but there is also people who have joined for the first time. So if you have any further questions, or if you would like to try SDC Verifier, we are happy to provide you with the trial license. We are happy to give you all our expertise, knowledge, and support for your evaluation or for your for solving your complex tasks, or maybe not that complex, but time-consuming tasks for evaluation of either offshore structure or whatever simulation you're working on. If it includes verification according to rules and regulations, let us know. We are happy to help you. And at this point, I would like to, yes, please.
So in your model, you have two structural analysis blocks linked together, so they all in the same session in mechanical. What if we have two separate blocks? If you will go to the workbench, you will see if we have two separate one, can you connect them into one SDC verifier block?
That's a good question. You mean if I add the separate one? Let me think. I never tried that one. I have one of our developers here. Bogdan, can you hear us?
Basically, that is the same options that you showed on the model.
Uh-huh.
You have different ways. You can just copy SDC Verifier project between the models.
Like
No, on the second, no, on the second node. On the model in SDC Verifier block,
yeah,
the model.
sorry. So you mean by
yeah, you have import from the same model. It means that you have the same block of geometry and static structural and so on.
uh-huh. Yeah.
Yeah, but you have also other options, for example, import as template, yeah?
Yeah, but I need to create a different model. So if
Yeah.
I create another one, static structural, I drag it here, for example. It would probably take a bit of time. Oh no, it's good. And then on this one, I create import as.
So you need to connect first SDC Verifier block to that, to the second model.
This one.
And then execute on it. Now you have create the first block. You have the already saved project of SDC Verifier. Now our task is to grab that project from this model to the second one.
Yeah.
So we need to run the command on the second model.
Yeah.
Then press import as template.
Yes. And
choose
select
the model
from
D.
which one we would like to do this.
Yeah.
Yes.
Yeah, but please be aware that the IDs of the models can be different. So
yes.
it can depend.
Yeah. Thank you, Bogdan. Thanks for your question.
Okay, so is it yes or no? Can we do that? Can we share? Let's say you have block B and block E. Can we connect B and E into D?
There's no direct way, but this is just the possibility to copy the scheme between two models,
Right.
Yes.
like
So
combinations and so on. Yeah.
yeah, the reason is sometimes we have different blocks, and now ideally we would have the one that you're showing here with block B and C. They all share the same configuration. However, sometimes we have mechanism that you have uh, you have different uh, configurations where, let's say, you have pack A and pack B, and pack B rotating around an axle on pack A, and it
What
can
are
have
Yes, question here is what are the loads there the same? Are the element numbering the same between,
the
let's assume, between B and E? Is there a lot of similarities between this model?
yes. So
Okay,
it's just that the same system, the same machine, but it may have different configuration in position. For example, a crankshaft and piston, right? You can put it in different position,
right.
but they own the same, sharing the same elements, the same everything the same, except for the position of the piston and the crankshaft. So can we connect, multiple position into one SDC block to analyze them together, like for fatigue or for whatever low combination?
Well, this duplication just copies the workflow, right, Bogdan? Correct
Yeah.
me if I'm wrong. Yeah, so you can copy the same structure, but it won't be like exactly in the same window. It will be, yeah, you will close and save this one and open this one with, well, it doesn't have anything to show, but open this one with exactly the same structure, but as a separate window.
Right. So it's after a
You will
copy
keep
that
the
is
combinations and setup, but it will be a separate block and separate window.
right. So if you update one of them, then you have to redo the change to the second one.
Yes,
Yes.
yes.
Yeah. What I'm looking for is the way you can pull all the different configuration and load
Mhm.
cases into one place and process as one,
Yeah,
as usual
understood.
in fatigue.
Okay, Bodan, is it something, what is the complexity for us for developing this? Is it is there any limitation that, but yeah, if we didn't do that yet, if it's just a matter of time, or is there any limitations to this?
Yeah, the connection to the two mechanicals, the first problem, and the second, the IDs between the models, because you may have not the same IDs for your basement, for example.
Mm-hmm.
Yeah, and the fatigue
Yes.
will not be calculated at the same element.
Yeah, so if the element numbering has changed, because we used element numbering for reading the outputs, if the element numbering has changed, that would require us, yeah, that would cause some conflicts. So that's the reason of this.
Okay.
Okay, thank you for your question. Really interesting one for everyone and something for us also to think about. Good. We are just about to fit within 1 hour. So
Can I ask one more question?
yes, please.
I would like to ask regarding backlink analysis in SDC Verifier. How exactly it choose the backlink length factor of beam elements? I mean, like in analyzing the complex beam system, the
Yeah.
most difficult task is to properly choose the correct backlink length factor, which are really case dependent and depend on the stiffness of the connection, the adjoining element. So
Yes.
how it's solved? Because I saw that it's recognizing beam elements, but not every beam element has the same backlink length factor.
Well, first of all, we are we open this thing, and are you speaking about the types of connections in here? So, I mean, if we are going through the member finder, we have a length factor here, which is automatically defined for every member. And Bogdan, do you remember how this length factor is calculated?
Basically, it's almost always 1, but except the free edges, because for the free end it's 2, if I remember well.
So user have a control of this, and if you have any specific cases and you want to change it, you are able to adjust, and it will be written here that it's modified. By default, it's 1. For some cases which are free edges or fixed, maybe it's changing into 2. And if you need to do some customization and modification, you can, like I did, the plot members with IDs, see which one is where. You can also probably plot with length factor. Yes, so you can select all of them, plot them with length factors, and take a look on that. And then if something has to be changed, and this is pretty strange why this one is 1. Probably I edited some of them. What? And so most of them are 1. The ones here are 2 with 2 fixes. This one free edge is also 2. So you can take a look on what is automatically defined and selected, and if you need any change or replacement, you are able to edit it manually. That's the idea.
Okay, thank you.
Thanks. Okay, if there are no further questions, I would like to conclude this session. Thank you for attending this webinar. Thank you for your interest in SDC Verifier. Once again, if you would like to dig deeper into any of this topic, send an email to support@sdcverifier.com or send an email to me personally, oleg@sdcverifier.com. Most of you probably have my phone numbers. I'm always open for a conversation about SDC Verifier, and our team is also here to help you. So whatever questions you might have in the future for offshore structure or whatever other design that you are evaluating and feeling that you are in need of some tips or tricks how to perform this analysis, feel free to contact us. And I was happy to speak to you today. Thank you, and talk to you soon. Bye-bye.